Good evening, gentlemen, ladies and gentlemen. We got a test review key to work through. I'm going fast. The integral of cosecant x. That's a little bit of a typo. I said I'm going fast. We're going slow. HO2. Hopefully you're already done with the first question. Get into unit 3, get into the test review. We need a variable on our cosecant. Come on, come on, come on, come on. All right. If you're still here, you're a true fan. It would be -1/2 the integral of cosecant squared. It comes from cotangent, but the derivative of cotangent is negative cosecant squared, so there should be another negative. Not dx plus c. I think that's it. 1/2 cotangent x plus c. It is late. I've been making test review key videos for like 10 different classes and I'm exhausted, so we'll see how we do. I'm thinking U substitution here. I'm seeing that I have an interior function and an exterior function. I'm seeing a pretty solid matchup of those things. These are going to switch up. I'm going to set this up as 6 integral of x squared cosine u du. Those switch 3x squared. The x squareds cross out. 3 and 6 will make a 2. So I'm going to set this up as the integral of 2 cosine u du. The integral of cosine is sine. 2 sine u plus c. 2 sine of x cubed plus c. Easy. I'm noticing that this denominator could be factored with difference of squares, but I'm also noticing that it wouldn't really work because x plus 2x minus 2 is not really doing anything. I'm looking at the top and I'm noticing that x squared as the interior function, 2x as the top. I'm thinking about, I guess I could do partial fractions. Lol. I think I'm just going to go ahead and set this up with U substitution. Right? Should be pretty easy. Yeah. Because the 2x and the 2x. Alright, this is easy. It's going to be 2x over u du. Those two switch. 2x. Perfect, perfect. The integral of 1 over u du. The integral of 1 over u du is the ln of u plus c. Swap these out. The ln of x squared minus 4 plus c. And you know what? Is it supposed to be absolute value? Depends on what your teacher says. I don't know. Up next, okay, it's the same denominator. Looks like we got a hint. If calculus won't seem to work, try algebra. Yeah, I'm not really liking calculus. If I set this up with u du, the 2x is not going to cancel out the 2x minus 4. So yeah, let's do some algebra. X minus 2, x plus 2. The top, a little GCF perhaps. Okay, now I'm liking that. 2 integral of 1 over x plus 2 dx. That looks like natural log. 2 natural log of x plus 2 plus c. Before I move on, plus c, plus c, plus c, plus c, okay. Let's go next. Okay, the test did say I needed to do these by hand. I could check this because it's a test review with my calculator. I see this is 2 separate things with the adding or subtracting, so I would probably break this up. 1 to 2, 4x cubed dx minus, and this is also a coefficient, so I'm probably just going to put that outside as well. 1 to 2 of sine pi x dx. Okay, this one over here is so easy. Add 1 divided by 4. X power 4 from 1 to 2. This one is a little goofy because I have this pi in there, and if I do u substitution, I would have pi x, the derivative would be pi. I would have to divide by pi. So this pi out here is going to get canceled out by u substitution. Minus 2 sine of pi x. But I have to take the integral of sine. The integral of sine. Sine becomes cosine. Cosine becomes negative sine. Negative sine becomes negative cosine, and negative cosine becomes sine. So this should be a positive now because the integral of sine is cosine. That's from 1 to 2. I need to plug all this stuff in. That would be 2 power 4 minus 1 power 4 plus 2 cosine of 2 pi minus 2 cosine of 1 pi. That would be 16 minus 1. Cosine of 2 pi is 1 plus 2. 2 times 1, and that would be cosine of 1 pi, negative 1. Well, negative 2 times negative 1 would be positive 2. It's 15, 17, 19. Double check with the calculator if you need to, but I'm feeling pretty good about it. Oof, we got a yapper here. Consider the quadratic function y equals x squared that has been translated 1 unit to the right and 1 unit down. Okay. Sketch the function. Be sure to accurately plot it. Write the equation of the function in vertex form. And then this looks complicated. Okay. Let's do A and B here. B is easy. Vertex form. Y equals x squared. It says right 1, down 1. Minus 1, minus 1. Draw my graph. Minus right 1, down 1. There's my vertex. I kind of know how these quadratic graphs go, right? Over 1, up 1, over 2, up 4. 1, 2, 3, 4. Over 1, up 1, over 2, up 4. After that, it's going off the screen, so. I think it looks like a pretty good graph. A, B. This equation has 2 x-intercepts. You are right. It goes below the x-axis for a short period, but then remains above the x-axis after the second intercept. Okay. Now what interval from 0 to k is the area above the x-axis equal to the area below it? Well, it says area, so I need to set up an interval. And it says 0 to k. And here's my function, x minus 1 squared minus 1 dx. Because it's talking about the area below the curve equaling the area, the area above the axis equaling the area above the axis. The below area is negative, the above area is positive. So if they are equal to each other, we should have 0. And so it's kind of like as we draw this, as we color it in, we have all that negative area, and so we got to start to build back some positive area. I don't know when it stops. Maybe it stops at 2.5 or 3 or 3.5 or something like that. So I can set this equal to 0. This is really sloppy. Let's see here. Oh, we're getting real crazy. Okay. I would probably algebra this here. The integral from 0 to k, FOIL that, x squared minus 2x plus 1 minus 1 dx plus 1 minus 1, who cares, equals 0. Integrals, that's easy, 1/3 x cubed minus x squared from k to 0. Plug in my k, 1/3 k squared, no, k cubed minus k squared. And then this would be minus 0 minus 0. Who cares about that? Sorry. This is all equal to 0. 1/3 k cubed minus k squared equals 0. Factoring time. GCF, k squared times 1/3 k minus 1 equals 0. K squared equals 0. K equals 0. Okay, that makes a lot of sense. If my interval was from 0 to 0, the area above and below would be equal because they would be nothing and nothing. So okay, that's kind of cheeky, right? It's kind of dumb, but it's kind of cheeky. 1/3 k minus 1 equals 0. Add 1 times 3, k equals 3. So it is 3. It's kind of cool. Interesting. The area in this region is exactly the same as the area in that region. Go ahead and comment down below if you thought that was a real reaction, because I made this question up and I knew it was 3 the whole time. So, boom. That's crazy. Oh my god, how many questions did I put on this thing? We're doomed. Alright. We gotta go faster. Come on, please. Find all values of n that would allow you to use partial fractions to integrate the function. Partial fractions requires me to be able to factor. So how many different values could n be to allow me to factor this? It would be all the factors that would make 10, which is 1 and 10 and 2 and 5. It's plus, so it could be plus plus or minus minus. So my options would be n equals 11, n equals negative 11, n equals 7, n equals negative 7. Those are my only options. I can't do a plus or a minus because it says plus 10, so I can't do anything like a plus 3 with a positive 5 and a negative 2 because it has to be negative 10. So that's it. Okay? Easy. B. Choose one value for n and integrate using partial. Which one do we want to do? Which one are you guys most likely to choose? Probably not one of the negative ones. 11 or 7. If I choose 11, it'll be 1 and 10. Those are easy numbers. All right, let's do 11. The integral 24 dx, and this is going to be x plus 1, x plus 10. Partial fractions. 24 equals a, x plus 1 plus b, x plus 10. First, I'll try x equals negative 1. That would get rid of my a's, and it would make this 9. 24 equals 9b. b equals 8 over 3. Okay, kind of stupid, but whatever. And then let's do x equals negative 10. That's going to go away. That's going to be, oh my god, stupid, negative 9. Negative 9a. Excellent. A equals 24 over negative 9, which is negative 8 over 3. Now remember, the A has to go on top of the other one that it's not touching. So, this desk, junk everywhere. All right, partial fractions. That would be the A needs to go with the x plus 10, and the B needs to go with the x plus 1. All right. X plus 1 goes with the B, which is 8 over 3. Minus, I did the A second because I knew it was minus the 8 over 3 x plus 10 dx. Two separates. 8 over 3, 1 over x plus 1 dx, minus 8 over 3, 1 over x plus 10 dx. Integrals. 8 over 3 natural log of x plus 1 minus 8 over 3 natural log of x plus 10 plus c. You know what? I'm not even going to bother to combine them. I don't think I need to. I think this is good enough. C. Choose a value for n that does not lead to using partial fractions and integrate that function. There are solutions for n that are easy and other choices that lead to lengthy solutions. So, if it is not, this paper is just absolutely driving me crazy. I'm getting old and tired. I know that if it's not going to be partial fractions, it's not going to be natural logs, it's going to be arctangent. And the arctangent formula is the integral of 1 over a squared plus x squared. Is that right? I don't have my formula booklet with me. Quick, Google. Derivative. I guess it's plus. So it doesn't really matter. Okay. That means I need to set this up with complete the square, which is easy. Any number I choose could complete the square. But I want this A to be a perfect square. If I choose something like n equals 4, then I'll have the integral 24 over x plus 2 squared plus 6. But 6 is not a perfect square. My perfect squares are 1. Okay. 1 is definitely the easiest. I like 1. I like 1 because we're starting off with 10, and if we have 1 left over, that means we used up 9 for the difference of squares, which means we should have x plus 3 squared plus 1. And that plus 1 is going to make it pretty easy. It's going to be, this 24 is going to always be out there. The arctangent has the A on the bottom, but it's just a 1. So who cares? x plus 3 over 1, but who cares? So just 24 arctangent x plus 3 plus c. If we did like this question here, which is not as nice, 24 over square root 6. Ew. Arctangent of x plus 2 over square root 6 plus c. Disgusting. But you know, maybe it's actually easier because we didn't have to think as hard. Alright, 2 more pages. This actually looks pretty easy. The following diagram shows the graph of position, velocity, acceleration. Okay, this is super easy. I know that the way these work, position, velocity, and acceleration, is that as I take the derivative, we start at position and they degrade to velocity and then acceleration. So when I see that graph A is this cubic graph, the most complicated one, that's got to be position. And then it's going to downgrade to graph C, and then it's going to downgrade to graph B for acceleration. That was easy. B, state the value for t when, okay, this is so easy. Velocity is highest. Easy. T equals 3. Oh, off the page. T equals 3. We're cruising. If the velocity of an object traveling in a vacuum can be modeled by the equation of v of t equals 1/2 cosine pi x in radians, find the displacement after 1 second. Calculator permitted. I do C. A. That would be the integral from 0 to 1. 1/2 cosine pi x dx. Calculator time. Alpha window 4 from 0 to 1 of alpha y equals enter 1/2 cosine pi x dx. Maybe I'll even close that. Teacher's pet. Hold up. Radians. 0. Why is it 0? What? Oh. I don't even need the integral, just 0.5 cosine. Let's just look at the graph. I see. Window. Well, we want to look. Let's do -1 to 5. Let's just do 11. And we want to look from 1 to -1. Nope, -1 to 1. Yeah, so it's just going up and down. So the area under the curve from 0 to 1 is the positive piece and then the negative piece, and they're the same, so it makes 0. So, okay, so what about 1.5? B. Just trying to get my points by writing this every time because I don't want to lose any freebie points. Go up, copy it, go back to the beginning, 0.5, enter. Okay. -0.159. That's because I am positive, negative, negative. So I actually do have more area negative. All right, what about Last question. Delete, enter. So that E means scientific notation. So I have 0.000000000. Okay, so it's just 0. Use your knowledge of trigonometry to find an interval where displacement is greatest. I like my graph now. Because what I want to do is try to find where I can make an interval that is super positive. So I could maybe do like a negative. I could do... Basically, I just want to pick like this triangle up top, or this triangle, or this triangle, or this triangle, this triangle, this triangle. So I have a lot of options, actually. I think they all should be the same. They all should be the same. Let's do this positive one. 1.5 to 2.5. Let's see how that looks. Grab this one. Change it from 1.5 to 2.5. Yeah, I think that's it. I think we got it. 1.5 to 2.5 of 1/2 cosine pi x dx is equal to 0.318. I think that's as big as it gets, because I think if we do the same thing from negative 0.5 to positive 0.5, yeah, same number. So we're in good shape, right? Because if we go any further, we're going to start introducing negative numbers. It's going to get smaller. Or if we go backwards, it's going to, yeah, so we're good. Please. It is, oh my God. What am I doing? This has got to be by parts. There's no way anything else is working. U substitution, there's never a chance. By parts. U, give myself some kickstands because I've also got V's and DV's. My priority is E's and sines, so I'm going to go ahead and put sines down here. So this is going to be 3x squared plus 4x plus 1. 6x plus 4. The integral of sine, I think we did that earlier. It was negative cosine. I don't ever use dv again. It is u and v. 3x squared plus 4x plus 1 times negative cosine x. Okay, minus the integral of these two. 6x plus 4 negative cosine x dx. And we're going to have to let it rip one more time because we degraded, but not quite enough. One more lap should work, however. U equals du v and dv cosine x 6x plus 4 derivative 6 integral sine. Never going to use dv again. Negative. Maybe I'll put the cosine at the front. Doesn't matter. Alright, this whole thing here would be u and v plus sine x 6x plus 4. Subtract the integral of these two. I'll put the 6 out front. Sine x dx. And I have to do the integral of the sine. Negative cosine x 3x squared plus 4x plus 1 plus sine x 6x plus 4. The integral of sine x is, we did it up here, negative cosine, which is going to turn that negative into a positive. Positive 6 cosine x plus c. My boy. I think we're good. Integration by parts, so easy. Disgusting. I'm going to bed.